So my name is Mulliner. I'm a student of the Reliable Software Group at UC Santa Barbara, and I'm doing some security research on Bluetooth and other stuff. And today I'm going to talk about advanced attacks against pocketPC phones. But actually that's only half of the truth, since we're actually going to talk about MMS-based attacks against pocketPC phones. So, basically, So we're going to talk about attacking and exploiting pocketPC-based smartphones, about vulnerability analysis of smartphones, and applying fuzzing to smartphones. In this particular case, we're looking at the MMS, the multimedia messaging service. And of course, we are going to looking at the client side, the user agent side. So basically, we're going to look how to analyze and then how to attack the pocketPC MMS user agent. So first, a small overview about mobile phones, state-of-the-art attacks, a little bit about pocketPC, the multimedia messaging service, then vulnerability testing of the multimedia messaging service, and then some nice exploits and how to own MMS user agents, and some conclusions, of course. So right now, the basic attacks against mobile phones are either Bluetooth-based attacks, where you just take control over the phone using some logic errors, where you can steal phone books or use it to do denial of service attacks, or you attack third-party applications, do some code injection, some denial of service, or if you go to SMS, MMS, we have these MMS worms for Symbian, which don't really utilize real vulnerabilities. It's more like, let's see if the user is actually dumb enough to run this Trojan. And some common examples are the Convoy or the Mabir worms. And then we have the SMS-based attacks, some format string exploits, which basically can only be used to crash the device. Or the Siemens thing, some special characters. If you send an SMS with a special character, the phone just freezes. Very, very stupid, not very advanced. So we're going to do advanced attacks. So pocketPC was exploited about 3 years ago. There was a first talk about DEF CON, I think 11. Or 12, I don't know. So the basic things are, okay, we can attack some third-party applications, preferably FTP servers, or we can do some attacks against the Bluetooth stack. There's actually a nice, not really public exploit, because Microsoft said, oh, we're not going to fix it, the next version is getting out. So Tim Herman of our group, he wrote this really nice exploit. Then we have some other Bluetooth OBEX-based attacks. Nothing, it's cool, but not that great. And then we have some denial of service, if I could active sync, or some local attacks which are kind of stupid against PDAs, but they're there. So quick overview of what is pocketPC. So pocketPC is actually just the Windows CE versions used for PDAs and smartphones. There are a bunch of architectures supported, but we are actually only interested in ARM. Also, we're not going to do any shell code or things today. The current version is 5.0, but there are so many 4.2 devices out there. So we're going to look only at 4.2. So that's basically the phones the devices we're interested in. It's just 2 examples, where we have GSM, wireless LAN, Bluetooth, infrared in one device. So these kind of phones are we going to attack. Some quick overview about Windows CE. So we have this Windows CE only has like one virtual address space for all applications or all processes, which is divided into this really stupid slot structure. We have basically a 32 process limit, and yeah, there's kind of memory protection. So yeah, it's really stupid OS. But we are not going to look at the real details. We're actually only interested in MMS. So the security model is also really cool. It's a single user device, and you can just lock your device. So any process can access like everything, which is really cool then, because once you're like execute code, you can just like, oh, let's use Bluetooth. Oh, why not use GSM and call some numbers? Yeah, you can just do anything. So the reason why I'm not going to talk about shellcode and stuff is because it's pretty well covered by now. So if anybody's like into writing their own exploits, check out these talks and use the stuff I present today to write some nice shellcode. So there are some issues like on Linux or Windows, you have like a command shell, so you actually just want to do one thing. You just connect or exploit a box and run a shell, and then you have access, but not on pocketPC. So you actually have to write everything you want to do in your shellcode. So it's going to be a little bit ugly. And then we have the stupid slot problem, where we actually have to like guess the return, a specific part of the return address every time new. That's kind of annoying. There are some workarounds. I'm gonna show them later, but they're well covered in the other talks. So that's the actual thing we're interested in, the multimedia messaging service. Many people, I guess, know it either at MMS or as picture messaging in the US. Yeah, since I'm from Europe, we just call it MMS. It's basically just a multimedia message exchange system. It's basically built like really audio, video, pictures, text, of course, but you can actually send anything. Yeah, just some data exchange like email. So like email, messages are sent like in a store and forward manner, so you actually have a big infrastructure in the back. And of course you have to pay per message, which is kind of interesting if you try to analyze a system like that, because we don't actually want to spend money. So the architecture, even if it's like a phone thing, it's totally IP based. So if you're like kind of skilled in all the IP stuff and HTTP, WAP maybe, yeah, you know how to mess with MMS. The system is basically just like 4 components: the MMS server, a relay, a gateway, the push proxy, and the SMS service center. So the interesting thing. So when a message is sent, of course the client generates the message, and then it's actually just first a WAP push to the WAP gateway, which just translated to HTTP. And so it just uploads some stupid file to some web server. That's basically how MMS works. The receiving side is a little bit more interesting, because the device somehow needs to know there's a new message waiting for you. So that's just going to happen via SMS. So as soon as a new message is waiting for you on the server, you just get an SMS. And then you just go to the server and the same way just use WAP over the WAP gateway, do HTTP, and get the message. So the matches is just like, yeah, email. So we have some headers, some bodies. The bodies, like in MIME, a really nice format, especially if it's binary encoded. You can do a lot of nice and funny things with it. By the way, if there are any questions, just rave and get a mic. So they just do binary encoding, of course, to reduce message size, which is kind of interesting later. So we have a bunch of messages. There are message types. They're not too interesting. besides the notification message. So just for reference. So what is the user agent? Of course, it's like the MMS client application. It sends and receives the stuff. It handles, of course, SMS, web push, all the IP crap, and of course it has to render lots of formats. SIML, WML, it's like HTML for MMS. And of course all the different audio, video, image formats. It has to do a lot of stuff. So the pocketPC agent, they call it the inbox application. And the fun thing, it handles everything, every communication like SMS, MMS, POP3, IMAP, and yeah. And again, for reference, the versions I was working with are these two. So maybe somebody has like a device like that. Maybe he wants or she wants to switch the device off, because maybe I'm going to do a demo later. The application binary is called Tmail access, so just if you want to look at your device, that's the application we're going to mess with. So now if you want to actually analyze and see and attack the agent, we first, of course, need to know, okay, what kind of inputs does this application have to handle? What are the possible attack vectors? And then we have to look at the infrastructure, because all our messages we're sending to the device are going through the infrastructure. The infrastructure could just filter out sanitized parts of the message and maybe filter out like bad stuff we are sending. So we're going to have to look at that. And then, since we not want to pay for message delivery while testing, we're going to build our own infrastructure and use that for fuzzing. But yeah, more on this later. So basically there are two different messages which are sent to the device. It's the notification. This is the part that's sent over SMS, which has the information about the new message. And then we have the receive conf message. This message is basically the file you download from the web server with just a normal HTTP webget. And then we have, in the receive conf, of course, we have like a header part and a body part. The body part is really nice, complex, binary encoded MIME multipart. If you ever looked at a MIME encoding and then just think about how it would look like in binary, yeah, it's fun. So, yeah, the infrastructure. So every time we send a message, the infrastructure, or the MMS relay, is going to look at the message and say, oh, what's about that header? Oh, that's maybe incorrect. So we're not accepting that for delivery. So in order to actually find the vulnerabilities or exploit them, we need to know what parts of the message we can actually modify to a certain extent before it gets rejected. So that's what we're going to do. I implemented a kind of fuzzing like testing procedure where we just like modify fields and just record the behavior of the MMS relay to see, okay, this is acceptable or not. So the message headers are basically sanitized heavily, and it's mostly unusable. But the message body is more interesting anyway, since there are many more possibilities there. And the nice thing, they don't touch it. So, yeah. So yeah. So if we look closer at the MMS delivery on the phone itself, we see that we get a web push, which is, you can do it over UDP, but they send basically the same message just encapsulated in an SMS. It's sent normally from port 9200 to port 2948. These are SMS ports. So in SMS you can also have those port identifiers. Then we have this nice thing on the device called a push router. The push router basically just gets all the web pushes and forwards it to the application. So and if you have this VND WAP MMS matcher thing, the MMS client is going to get it. And so the real fun thing is the message, the URL where to receive the actual message. That's just part of the notification. There's really just a URL string like here is the message, get it from here. And now the really bad fuck up of Microsoft. The pocketPC device who have wireless LAN also accept the WAP push message on the wireless interface. So as soon as you fire up your wireless interface, I can send you a lot of nice WAP pushes. So that's like how the notification looks like. So you see at the end the red part. This is just the URL where the message is waiting for you, and then you see the blue part is the WAP push, just some information. You see some transaction, the subject, it's all in there. So what you actually can do, you can just build your small WAP message generator and then just start sending WAP pushes over wireless to your device, and your device will think, oh, there's an MMS waiting for me. And your phone will try to dial up GPRS, and the sound is also very, very annoying. And if you send hundreds of messages, thousands of messages, your phone is going to be very, very slow. And you can do stuff like, oh, fill up the MMS inbox, the file system, and you cannot do like select all and just delete the junk message. You have to go through and delete one message by one, which is a really, really nice DOS attack. So of course we're going to publish a tool. Also the tool is not, I haven't put it on the website yet. So actually the trick is for the flooding is to make the phone believe each message of course is a new message, and the thing is we just have to have a unique transaction ID and content location. So if you look at the slides later with the notification printout, you can see what parts you have to modify in order to have a nice small unique notification message. So, and yeah, if you that could happen to you today if I put the tool online.
Are you saying that phones actually go get messages even when they're not there?
No, that doesn't work, but because of some of the web, since you have to go through the WAP gateway of your phone service provider, they're of course blocking access, or some of them block access to servers which are not their MMS servers. But yeah, your phone will like try 3 times per message, so it will try to dial up GPS, try to do a connection. Yeah. So, but yeah, that's just like the small side effect, the small fun we had on the side while doing that. Because actually we're going to use the UDP stuff for something else. So we want to find real exploitable bugs in the application. And since we don't have the source or anything, we're going to use fuzzing. And fuzzing, probably most of you have heard of it. It's just you build like semi-valid input and send it to the device and see how it reacts. So the problem, of course, with MMS is, each message will cost you about like 25 cents maybe. So if you want to send like 5,000 messages to do some testing, you have to pay a lot of money. So we are going to just build us our own MMS infrastructure. It's, since we only have a web server, we have a web gateway, so we can just get off the shelf stuff from the internet, set up an Apache web server, the web gateway, get the MMS message generator, which we're also going to release our customized library, but it will take some time. And we do the actual simulation of the MMS infrastructure by using the UDP port. So Microsoft actually gave us a really nice debugging tool with this UDP port, because now we can 100% simulate the MMS delivery process. You just have to change some settings in the MMS client and say, okay, use this IP, like our Apache web server and our web gateway, to get messages. So we can generate some messages, put them on the web server, put them on the web server and send the notification. So we basically were just after basic buffer overflow, string length stuff, just some basic testing. And so you just hook up the debugger to that Tmail exe, generate some message, dump it into the web server directory, and send the message notification. So the phone will retrieve the message from the web server. Either it does nothing and just looks funny, or maybe it doesn't show anything, or maybe the Tmail exe will crash and you get some nice exception. So this is a printout of the actual receive conf. It's not complete, of course, because it's kind of big. So in the beginning we see like the phone numbers, and then we have the nice multi-part headers. In the middle there is the text file, and then we have the XML file at the end. So it's just for your reference. So, of course, the simulated infrastructure really helps, because the ISP infrastructures are really undeterministic. Sometimes the messages are not delivered promptly. So the simulated infrastructure really helps to do deterministic testing. Also, maybe we want to test the parts that are normally sanitized. So we can, with our infrastructure, we don't have this whole sanitization thing. We just generate files and feed them to the phone. And of course, GPRS is kind of slow. Maybe if you have Edge, but still the whole thing is kind of slow. And with the with our own infrastructure, we can really speed up the process. And of course, we don't have to pay our whatever 25 cents a buck, or however how much the provider is going to charge us. So that's really nice and makes the whole testing really relaxed, so you don't have to think about spending money for stupid messages. So, and then, yeah, the first bugs we found in the notification in the notification message, and there are just like 3 stupid buffer overflows. So if you just make the transaction ID like 264 bytes, the MMS client just like dies. So, and if you remember, you can send this message over UDP. So as soon as the wireless is up, you just go out, send a nicely modified notification message, and you can crash Tmail exe. Unfortunately, all these overflows are not exploitable for code injection. You can just overwrite parts of the stack, and the application just goes away. So the bad thing is, okay, you see when I want to like write MMS, I don't need to be on the wireless. But since the application is also handling emails, so maybe you want to check your email, and at that point, we just fire. And so anytime your wireless interface is up, you cannot read emails, SMS, MMS, a really nice one. Then we have some other bugs in the mretrieve config. That's, they're not so interesting. So in the body, this basically is the same bugs, but for some stuff we cannot exploit it because we have the stupid sanitization. So what we could do, this is just what we could do. We actually haven't tried it, and because many mobile phone service providers actually like run these stupid closed web gateways, which don't allow us to connect to our own rogue web MMS server. But if you find an ISP which doesn't block access to other IPs, you can just run your own MMS server on their network or just on the internet and send a nice SMS which points to your server. So, and whoops, you can exploit all the other bugs you just found, which were normally not exploitable. So maybe you want to try to test some other service providers. I just did like this, the big in the US and in Germany, and they're smart enough to deny this access to other MMS servers. But yeah, maybe you find something and whoops. So now it gets interesting. We have the SIML is this XML-based presentation language, basically the HTML for MMS. And the really cool thing about that is this is, of course, transported in the message body. So everything we put in the message body, as I said before, is not sanitized. So, whoa, that's a perfect attack vector. Maybe we find something there and really screw you. So that's basically how a file like this looks like. It's just looks like HTML. The green and the red region is going to be interesting because, yeah, there are some exploits. Actually, the implementation is that bad that for these, they just copy the stuff within the double quotes to the stack. So if you put like 600 bytes there, 800 bytes, whoops, just on the stack. We don't care about the size. It's probably the same parser which just operates on different tags. So yeah, so maybe this is a nice exploit. But so how in order to actually send our own bad MMS, we first need to build our own MMS user agent. And since we know how MMS actually works, this is going to be quite easy. So we basically use a MMSlib to generate some MMS thing. I use a really stupid Java library to just handle the web stuff, since I didn't really care about re-implementing the shit. And then you of course have to use GPRS dial-up in order to connect to your service provider, because the MMS relay, of course, is not reachable from the internet. That would be so stupid. Or of course, sometimes the whole infrastructure is just in a private IP range, so it's not connectable by the internet anyway. So building a MMS user agent is actually quite easy, and yeah. So yeah, the 0 day. We can actually use this exploit from before, the vulnerability, to just do some remote code injection over MMS. And not like the other MMS things where you just have to like install and it's okay that the application is not trusted. You just click on it like on an email, and as soon as the viewer goes in action, bang, code executed. So yeah, there is some. So on the left side, of course, it's just like the inbox. And yeah, if you click on that little message, whoops. Yeah, so maybe somebody want to try this at home. Yeah, so as I said, I use these two devices. I really don't know how many devices are affected. But yeah, if you want to try this, there are the return addresses, the stack size, and so the slot problem I mentioned in the beginning it's actually really, really stupid. So you actually have to guess on which memory slot the T-mail is going to be executed. And what I found is like 14, 16, 20, 24, of course, hex are the common slots. So basically what you do is just not send one malicious MMS, you just send 4, and maybe the user is stupid enough to try to execute all 4. And at some point, we will have him. So yeah, have some fun with that. Oh, whoa. I'm way too fast. So of course I've talked to Microsoft and the company X, who doesn't want to have his name mentioned, but actually the name is on the slides I submitted because they responded like very slow in the beginning. So they really showed that they took it seriously, because one of their VPs, of course the marketing people, since they don't have one single security guy in the company, he was like, "Whoa, we can't do that. You can't publish that." And but in the end, they were actually very slow. It's very fast. Sorry. So in about a week, they actually managed to bring out a fix, and the fix is now sitting at the OEMs because they need to be tested and approved before they can be released. So as far as I know, they haven't been released. So you have, I guess, maybe a week or two to exploit this. But yeah, do it with your own devices, not with your owned devices. So yeah. So some defense stuff, really, really fast. Of course, you could like just run a packet filter on your device on your pocketPC. I actually haven't tried that because I was way too lazy. And for the MMS stuff itself. The ISP, of course, could run like an IDS or some antivirus thing, which I already do. But yeah, I didn't have a problem getting messages delivered over 4 different ISPs. So I guess they don't do any kind of detection until now. Of course, you can also run like some IDS or antivirus on your phone. Yeah, but yeah, I guess today is the first day they know about this, so yeah. So yeah, and yeah, what mobile phone providers actually should do is they should actually filter this SMS notifications over SMS, since actually nobody else besides them should be sending these notifications, because you also can crash the application over a real SMS. And yeah, of course, install firmware updates when available or soft updates. So the problem, yeah, security testing for smartphones is like really, really painful, because you have this infrastructure, you don't have source code, and in some cases, yeah, if you're like doing the security engineering side, then the MMS user agent is talking to everything, like to the GPRS, mobile phone network, and to Wi-Fi. So you really have to be careful what you're doing. So we found about like 10 exploits. We actually stopped searching after we found stuff we could use for code execution. We will, of course, post a nice advisory on the list. Yeah, and yeah, we did the first code injection against mobile smartphones, and yeah, there will be a major, major problem in the future if the companies don't watch out about that. So let me see. Oh yeah. So I was really too fast. Yeah. So in the future, of course, we have to look at other MMS implementations, and like the Symbian, Palmer stuff, the new Linux phones. We haven't really looked at that stuff. And then, of course, all the other parts of the MMS message. We haven't looked at the audio, video, parsers and handlers. So many things to test. And then, of course, we could also attack the actual MMS infrastructure. There are so many different protocols in there. You can really, really mess it up. So, yeah, I was really too fast. So we have a lot of time for questions. If anybody, go ahead, take the mic. And so I guess I have time. Are people here with like pocketPC phones? So we can do some demo. If you have wireless on, I can do that.
How often does the phone have to be?
Huh? Is it on?
How off does the phone have to be? Like airplane mode and Wi-Fi off, Bluetooth off?
For the Wi-Fi stuff, of course, you just turn off Wi-Fi and then you're secure against the Wi-Fi based stuff. But for the MMS stuff, yeah, you have to not read MMS. That's the only thing.
So just leave it in airplane mode?
Yeah, but then your phone is like off and not usable. So you should basically use a PDA maybe.
When you were testing and you found that all the major carriers prevented the client from connecting to a rogue server, did you try running a server like on a device that's actually on their network, like a cell phone or? Yeah,
we tried that, but not with all providers, with some. And yeah, I guess the European and the US providers are really up to date with their MMS stuff. But I found online in the MMS actually developer forums online, they give you so much nice information, and people are like, oh yeah, I think like in the former Eastern Bloc countries, I think some providers still just run totally open networks. But apparently the German and US stuff was open, I think, until 2 years ago, because I saw posts where people were just, oh, I want to play with MMS, and people are just like reconfigure the MMS server. Just go ahead.
So how about the future? What about 5.0? Is it super secure? Because I have a personal, this kind of hits me personally because I do have a 5.0 phone, but no, wireless is not on.
So yeah, I only, yeah. Was it that? No. So I never actually had like a 5.0 phone, but a friend told me that apparently 5.0 is completely compiled with stack protection. Yeah, I really don't know. Some people looked at it and they said, oh, there is no way in. So I haven't looked at it. I cannot say anything. But you should be able to at least be able to crash the application over UDP.
How is that possible? Because the exploit is based on MMS. I mean, does 5.0 somehow look at the header as well as the body?
No, so stack protection just like checks that if you overwrite the stack, the function doesn't return, so your code is not executed. So it basically just gets converted to a DOS attack, which is kind of stupid over MMS since you actually have to pay for it. But the UDP attacks should still work. Yeah, I really haven't tested anything about 5.0, so maybe I can get a 5.0 device and look at it.
Preferably not mine. Appreciate it.
The fuzzer you used, did you write that yourself or did you use another application? And if you wrote it, will you be releasing it?
What application?
The fuzzer you used.
Yeah, that will take some more time since it's actually a university project and we have like a scientific paper on it, so we keep it until then. But it's going to be released this year. The other application, the DOS tools, everyone can try it out, will be released later. As soon as I get off stage, I will try to put it online together with the updated slides.
And one other quick question. Are there other services that you're attacking? Or is it just MMS that you're interested in?
We're just looking at MMS.
Okay. Thanks.
Anybody else? I guess I still have like 10 minutes or something. No dance. So any volunteers for like putting up firing up their wireless?
Did you say you wanted to test Windows Mobile 5?
No, not on stage. So no volunteers. Or I actually thought like people were like screaming to like volunteer for stuff. Normally people always want to volunteer and like, oh yeah, I want to do the thing with the guy on stage, but not it's your phone, huh? Please use a mic. Okay. I guess I'm like totally under time. Oh, another question?
Yeah.
Thanks. So I don't get in trouble with the DEF CON crew.
I was just saying, could you expand a little bit more on the SMS ports thing? Is that's in standard SMS messages? There's like a port field or something?
Yes, exactly. But like the attacks over SMS itself, that's not as interesting because you actually have to pay for it.
Yeah.
So the thing is, the SMS ports are, so the whole port thing for the web posts are just mirrored one-to-one between SMS and UDP. So it's basically, yeah, they just map it to the same port, so you can send it over UDP. And according to the Microsoft security guy, we're just following the standards.
I volunteer my phone for a demo.
For two? No. Just hook it up to the DEFCON network, and I will do this. I just have to hook up my laptop to the DEFCON network. And yeah, I don't need your IP since Microsoft accepts actually messages sent to the broadcast address, so you don't have to search stuff. So you actually don't have to search. You just like, yeah.
I have a question while you're thinking about that. Do you have any idea why Microsoft allowed the UDP notification messages? Like, do you have any thoughts about what their reasoning might have been?
Because they're just following the standards. That's what I was told. I'm not going to. Oh, you have 5.0? Let's see. So is your device on?
Can you look at top of this plate?
You don't see anything on my laptop. Yeah, give me the IP for now. Sure. Did you get anything? Still nothing? Oh, bummer. Anybody with a 4.2 device? Okay, so I guess that's it. 5 minutes early, but